Hey everyone, welcome to my channel. If you like tech and helpful tips, don't forget to subscribe. Let's get started.
Navigating restrictive network environments or securely accessing internal resources often presents a significant challenge, especially when direct VPN connections are blocked or complex firewall rules are in play. This technical overview focuses on a clever workaround, setting up a VPN connection by leveraging AnyDesk's built-in TCP tunneling feature. AnyDesk, primarily known for remote desktop access, offers a robust TCP tunneling capability that allows you to forward specific TCP ports over its encrypted connection, making it an excellent conduit for VPN traffic that operates over TCP. Before diving into the configuration, ensure you have AnyDesk installed on both your local client machine and the remote host machine, which has access to your VPN server. You'll also need the necessary VPN client software on your local machine and administrative access to configure both AnyDesk and your VPN client. The core principle here is to encapsulate your VPN client's traffic within an AnyDesk TCP tunnel, effectively making your local machine appear to be directly connected to the VPN server from the perspective of the remote AnyDesk host. First, identify the TCP port your VPN server listens on. For instance, OpenVPN operating in TCP mode typically uses port 1194, or sometimes 443 if configured to bypass firewalls. Once you have this port, establish an AnyDesk connection from your local client machine to the remote host. With the AnyDesk session active, navigate to the Actions menu on your local AnyDesk client interface. Then select TCP-Tunnel. Here, you'll configure the new tunnel. You'll need to specify a local port. This is an unused port on your local machine, e.g., 10,000, that your VPN client will connect to. For remote host, enter the IP address or hostname of your VPN server as it is accessible from the remote AnyDesk host. This is crucial. If your VPN server is on the same network as the remote AnyDesk host, it might be a private IP address. If it's an external server, use its public IP or domain name. Finally, for remote port, enter the actual TCP port your VPN server listens on, e.g., 1194. After configuring these settings, click Add and ensure the tunnel is active. With the AnyDesk TCP tunnel established, the next step is to reconfigure your local VPN client. Instead of pointing your VPN client to the actual VPN server's IP address and port, you will now direct it to connect to your local machine's localhost address 127.0.0.1 and the local port you defined in AnyDesk, e.g., 10,000. So, your VPN client's configuration file or settings should be modified to use server 127.0.0.1 port 10,000. When you initiate the VPN connection, your VPN client will send traffic to 127.0.0.1:10,000. which the AnyDesk tunnel intercepts, encrypts, and forwards to the remote AnyDesk host. From there, the remote AnyDesk instance decrypts the traffic and forwards it to the specified VPN server and port. This setup effectively creates a secure, nested connection, allowing your VPN traffic to traverse restrictive networks that might otherwise block direct VPN attempts. While this method introduces some latency due to the double encryption and tunneling overhead, it's an incredibly powerful technique for bypassing firewalls and securely accessing resources when traditional VPN methods are unfeasible. It's important to note this method is primarily effective for TCP-based VPN protocols. Thank you for watching, and don't forget to like and subscribe for more technical insights.